So, lesson 39, we're going to start it today. We're not going to finish today. We are going to talk about radians. Radians is just another measurement of angles. So before we talked about degrees, now we're going to talk about radians. We're going to introduce the idea of radians. Now, you guys already know a radian measure. And you guys know this word, pi. And most of us know that pi is 3.14 something something something, right? And so we have, it's 3.1415.
92654.
There you go. Now, this is pi, guys. This is radians.
Valentine's Day, my own Valentine's Day.
So, anytime you have pi or any form of pi in sine, cosine, or tangent, or as an angle, you know you are in radians. So degrees of a circle went from 0 degrees to 360 degrees. In radians, it goes from 0 radians all the way to 2 pi. Okay? Now, so how does this help us? Well, it helps us for the fact that 2 pi is equal to 360. Or 360 degrees. Or, if I divide both sides by 2, pi is the same thing as 180 degrees. So if I asked you where you are on the circle on pi radians, you would be at
180 degrees.
180 degrees. That means all of the other angles that we had on our unit circles, if you guys take out your unit circles, all of those angles, remember when I had time tested you guys and there were 2 blanks for the angles? Degrees? Radians is the other one. So what we need to do is, we need to know what were those angles again. We had 0 degrees, we had 30 degrees, we had 45 and 60, and we'll even go to 90. Those are all degrees. What would they be in radians? Well, in radians, you got to kind of think of 30 degrees. How many times does 30, or 0, okay, we'll start at 0 first. 0 would be 0 radians. You're just not going anywhere. Then you have to think of 30. 30, what's the connection between a 30 degrees and 180? Ben said it.
It goes into 186 times.
It goes into 186 times. So, would you guys agree that 30 is just 180 over 6?
Mm-hmm.
But wait a minute, 180 is the same thing as
Pi.
pi. So it just becomes pi over 6. 45 goes into 180 how many times?
45 goes into 180.
180 divided by 4.
4 times.
So it becomes pi over 4. 60 is pi over 3. 90 is pi over 2. So if you take your unit circle out,
Why didn't we learn this first?
we can do, now we have our angles, we can do them in radians.
No.
So what would it look like on that unit circle? I'm only going to do the first quadrant for now, because then it just becomes multiples. So everybody's good with this? If I went here and start with the first quadrant, this would be 30, 45, 60. This would be 0. This one is pi over 6. pi over, and pi over 3, and pi over 2. Here's the cool thing. If you have your unit circle out, the problems that we're going to start to ask you now, what's the cosine of pi over 3?
Pi over 3, the cosine would be square root of AB.
So now you have to kind of think of, now a lot of us want to go back because we're more familiar with degrees. But we don't want to work with degrees because we're in radians. So where's pi over 3? And you'd be like, it's here. What is the point associated with that? Do we remember?
The unit circle, it tells us.
On the unit circle, when you guys have, that point would be, I do believe, 1/2 square root of 3 over 2. And cosines, which one, x or y?
Y.
The x. And so therefore, the cosine of pi over 3 is 1/2. Okay? That's what we're going to have to do. But of course, they're not going to just do that. They're going to add a second one or a third function with this all in a row. So maybe not only should we worry about our unit circle, let's go to our reference triangles. In our reference triangles, it is a 30, 60, 90 triangle. I'll make that the bigger one here. But we don't want to use 30, 60, 90. We want to use pi over 6. Pi over 3. So what are the sides? 1, 2, square root of 3. Each one of these angles on the 45, 45 become pi over 4 and pi over 4, 1, 1, 2 square root. So, that's the new ones we have to know. And again, how do I know that 30 degrees is pi over 6? Is because 30 goes into 180 6 times. It makes it a little bit easier to remember it if you do it that way. Now, let's talk more about this. Let's go to second quadrant. Second quadrant is here. We have the one that goes down the middle and the other two. Now remember that in the second, third, and fourth quadrants, we start to use reference angles. Yes? We said this one was going to be pi over 2. This one, on the very far left, the bottom one down here, would be where? How far? All the way across. That would be pi, because it's 180 degrees. What's this one then? Pi over 3. It was a pi over 3 over here, right? Is that really a pi over 3? It was pi over 3 before because it was a 60 degrees, right? Or pi over 3 is a reference angle, or the angle. Is this angle to that spot 60 degrees? That's in the 120 spot, right? So it means it has a reference angle of pi over 3. Isn't that coming from pi? Shouldn't that be pi minus the pi over 3? So what does that make that? We don't have common denominators, so would I make that a 3 over 3? What's 3 pi minus pi? It's 2 pi over 3. Interesting. This angle and this angle are the same, and so is this one. How many times does pi over 3 go into pi?
2 times at least.
3. Pi over 3 goes into pi 3 times. 1, 2, 3. 60, another 60, another 60. So wait a minute. Then we moved on to, say, 45 degrees, right? That's pi over 4. Then we went from, what's another 45 from 45? 90. So that'd be 2 pi over 4. And what's 2 pi over 4?
6.
Pi over 2. If I go another 45 degrees, I am here. How many pi over 4s am I? 3. So it's 3 pi over 4. Right. This one here is 3 pi over 4. If you have your unit circle, this is looking a little bit better. Then, what's this last one? The last one would be the same as this one over here, which we said was pi over 6. This is annoying. So, it's pi over 6 here, which means this should be a pi over 6 as a reference angle. But let's think of this. Pi over 6 is 30 degrees, yes? So if I started with 30 degrees, I'd be here. What's another 30 degrees?
Then you'd be there.
I'd be at 60, which is here, which we would say is 2 pi over 6. And wait a minute, 2 pi over 6 ends up being
2
pi over 3.
pi over 3.
If I add another pi over 6, I'd be at 3 pi over 6, which ends up being a pi over 2. Add another pi over 6, I'd be at 4 pi over 6, which reduces to 2 pi over 3. Because 30 degrees goes into 60, if I just keep counting and reducing, I get some of these other angles. And then I add another 30 degrees, and I'm down here, which is 5 pi over 6. And if I add another 30 degrees, or pi over 6, I'd be at 6 pi over 6, which is pi. So that same process is going to go around the circle, and around the circle, and around the circle. You just keep on adding pi's over 6s, pi's over 4s, and pi's over 3s, and pi's over 2. Are there any questions on that? So what we're going to ask you to do, again, is 4 sine pi over 4 plus sine of negative pi over 3. I'm going to ask you to evaluate this. Okay, now go back to your reference. Go back to your reference triangles, reference angles. Pi over 4, guys. Pi over 4 is here. Pi over 4. What's the sign of pi over 4? It's square root of 2 over 2. We just drew the reference triangles. Plus sine, oh wait, first of all, when I do this, pi over 4 is in the first quadrant. So therefore, the value is positive, right? Okay. Next one, we want to take into account that I'm in the fourth quadrant, sign is going to be negative. So whatever it is, I got to make it negative. What's sine of pi over 3 then? Square root of 3 over 2. And then I simplify this. When I simplify this, 4 divided by 2 is 2. So this becomes 2 square root 2 minus square root of 3 over 2. Oh man, maybe I shouldn't have simplified that. Why?
Common denominator.
Got to get a common denominator anyways. So that means I'd have to multiply this by 2 over 2 to get that to be 4 square root 2 minus the square root of 3 all over 2. That's what I'm looking for. I'm looking for the exact value. I'm not looking for an approximation to put that on my calculator. Now, here's the biggest thing now that I just said calculator. Take your calculator out because you have to switch modes. You need to be in the correct mode. You are either going to be in D.
Dag.
I will put a different color here.
Degree or polar?
You need to be in degrees,
Or rad?
DEG, or rad for radians. You sometimes have to hit a button called, I'm going to say drag.
DRG.
DRAG. Sometimes there's a little button on there. Is it DRG?
Yeah, DRG.
DRG.
Wait, we have to put that.
Sometimes you hit this button on some of your scientific calculators to switch modes. If you're using one of the big fancy ones, you have to hit the mode button, and then you can go down and you can switch your modes. But you use degrees, you're in degrees. If you're in radians, you have to be in radians. Otherwise, you get the wrong answer. The reason is, if I asked you for 1 degree would be that little teeny little piece, right? That's like 1 degree. But 1 radian, guys, 1 radian is somewhere about here. Why is that? Because pi is 3.14. So that would be 1 radian, 2 radians, 3 radians. And then 2 pi would be 6.28. So therefore, there's 4, or 4 would be a little bit more down here. 4, 5, 6. So therefore, you have 6.25 radians all the way around. That's the difference. Okay? So be very careful on that. Homework is 3, 4, 5, 6, or 3 through 6 and 10 through 12.